Hello students, in this video you will learn few important questions from the chapter circles. These questions are very important for your board exam because these kind of questions keep on repeating and you need to be very thorough with the concepts. So let us start. First question, in the given figure PA is a tangent to a circle drawn from the external point P and PBC is a secant to the circle with BC as diameter. If angle AOC is 130 degrees, then find the measure of angle APB. You have to find this angle where O is the center of the circle. Okay, you have to find angle APB. Here radius is OA and PA is tangent. Radius is perpendicular to tangent, so angle OAP. This is 90 degrees. Angle OAP is 90 degrees. Angle AOC is 130 degrees. And angle AOC is 130 degrees. Okay. So what is this angle? What is angle AOP? What is angle AOP? It is 180 degrees minus 130 degrees. Because these two angles form a linear pair. It is 50 degrees. So this is 50 degrees. Okay. And in triangle AOP. We will apply the angle sum property. So what is angle PAO? It is 90 degrees plus angle AOP. It is 50 degrees plus angle OPA is equal to 180 degrees. So angle OPA is equal to 180 degrees minus 140 degrees. It is 40 degrees. Okay. So angle OPA, this is 40 degrees. Second one, a circle touches the side BC of a triangle ABC at P. Okay. And touches AB and AC when produced to Q and R respectively. Okay. When AB and AC are produced towards the circle, they meet the circle at Q and R. Okay. We have to show that AQ is equal to half of perimeter of ABC. Okay. We have to prove that this AQ is equal to half of perimeter of triangle ABC. See, in triangle ABC, what is the perimeter of triangle ABC? What is the perimeter here? Perimeter is sum of all sides. It is AB plus BC plus CA. Okay. And if you see this side, B is a external point. Point B is an external point. So the tangents drawn from B to the circle are same. So QB and BP. These both are same. Okay. And if you see this side, point C is an external point. Okay. So the tangents drawn from point C towards the circle are equal. So PC and RC, these two are the tangents drawn from the external point C and these both are equal. Okay. And if you see this clearly, point A is also an external point. So the tangents drawn from point A, that is QA and AR, these both are also equal. QA is equal to AR. Okay. And QA is what? QA is equal to AB plus BQ. Right? QA is equal to AB plus BQ. Okay. And AR is what? AR is AC plus CR. Okay. AR is AC plus CR. Okay. And here we have BQ is equal to BP. We'll substitute here. QA is equal to AB plus BP. Okay. And we have here RC is equal to PC. So AC plus PC. We are substituting RC is equal to PC. Okay. And we will add QA and AR. We'll get QA plus AR is equal to AB plus AC is equal to AB plus AC plus BP plus PC. Okay. What is BP plus PC? It is BC. Okay. We will write here AB plus AC plus BC. Okay. This is nothing but the perimeter of triangle. ABC. Okay. See here QA is equal to AR. Okay. So we will write AR is equal to QA here. So we will get here 2QA is equal to perimeter of triangle ABC. And here QA is equal to half of perimeter of triangle ABC. Okay. Next question. Two tangents TP and TQ are drawn to a circle with center O from an external point T. Okay. So this is a circle. This is the center O. Okay. This is an external point T. Okay. Now we will draw two tangents. Okay. This is TP and this is TQ. Okay. We have to prove that angle PTQ is equal to 2 angle OPQ is equal to 2 angle OPQ, this angle. Okay, see here OP and OQ, these both are radius. OP and OQ, these both are radius. So this forms an isosceles triangle. So the angles opposite to these equal sides are equal. So here OP is equal to OQ, then angle OPQ is equal to angle OQP. Okay, this angle is equal to this angle. We will assume these angles as x. Okay, and in triangle OPQ, we will apply the angle sum property. We will have angle POQ plus angle OPQ x plus angle OQP x is equal to 180 degrees. Okay, so angle POQ is equal to 180 degrees minus 2x. Okay, and OP is radius, PT is tangent, and OP is radius and PT is tangent. So radius is perpendicular to tangent. So angle OPT is equal to 90 degrees. Okay, and OQ is radius and QT is tangent. So these both are also perpendicular. So angle OQT is equal to 90 degrees. Okay, and in quadrilateral OPTQ, quadrilateral OPTQ, sum of angles is equal to 360 degrees. So angle POQ plus angle OPT 90 degrees plus angle PTQ, okay, plus angle OQT, it is 90 degrees, is equal to 360 degrees. Okay, so angle POQ plus angle PTQ is equal to 360 degrees minus 180 degrees. It is 180 degrees. Okay, and here we have angle POQ is equal to 180 degrees minus 2x. We'll substitute here angle PTQ is equal to 180 degrees minus of 180 minus 2x. So here 180 and minus 180 will be cancelled. You will get here 2x. Okay, PTQ, this we got as 2x. Okay, PTQ is equal to 2x. What is x here? X is equal to angle OPQ. So here it is 2 into angle OPQ. Okay, so we have proved angle PTQ is equal to 2 angle OPQ. Okay, next question. In the given figure, AB is a diameter of a circle with center O. OQ, BP and PQ are tangents to the circle. Prove that angle POQ is equal to 90 degrees. We have to prove this angle POQ is equal to 90 degrees. Okay. See here OA is radius and QA is tangent. So radius is perpendicular to tangent. It is 90 degrees. And OB is radius. BP is tangent. So these both are also perpendicular. Okay. And if you see this point, if you see Q point, it is an external point to the circle, and the tangents drawn from the external point are equal. Okay, and the line joining the center and the tangent, okay, this line bisects the angle between the tangents. This line bisects the angle between the tangents. Okay, so these two angles are equal. So angle AOQ is equal to angle OQP. Okay, we will assume these as x and x. Okay, so angle AQP will be 2x. Okay, and AQ and BP, these two are tangents drawn on the either sides of the diameter. Okay, so these two tangents are parallel. AQ is parallel to BP. Okay, so angle AQP. So angle AQP is equal to angle QPR. Okay, we will assume this point as R. Okay, so this is equal to 2x and this will also be 2x. Okay, and what is angle QPB? What is angle QPB? It is 180 degrees minus 2x. Okay, it is 180 degrees minus 2x. And OP is a line joining from center of a circle and an external point. Okay, so this line bisects the angle between the tangents. So this line bisects angle BPQ. So angle OPQ is equal to angle OPB is equal to 180 degrees minus 2x divided by 2. Okay, so this will be 90 minus x, because here OP is bisecting this angle between the tangents. Okay, so these angles will be 90 minus x. Okay, so angle OPB will be 90 degrees minus x. Okay, in triangle OPB, In triangle OBP, sum of angles in a triangle is 180 degrees. So what is angle BOP? It is x degrees. Okay. See, if this is 90 degrees minus x, this will be x. Okay. And in triangle AOQ, this is x. This is x and another is 90 degrees. So this angle AOQ will be what? It is 90 degrees minus x. So angle AOQ will be 90 degrees minus x. Okay. And AOB is a straight line. It is a diameter. So angle AOQ plus angle QOP plus angle BOP is equal to 180 degrees because it is a straight line. So what is angle AOQ? It is 90 degrees minus x plus angle QOP plus angle BOP is x is equal to 180 degrees. So here x and minus x will be cancelled. So angle QOP will be 180 degrees minus 90. It is 90 degrees. So angle POQ is 90 degrees. Next question. In the given figure, O is the center of the circle of radius 5 centimeters. So here OA is 5 and OB is 5. PA and BC are tangents to the circle at A and B respectively. If OP is 13 centimeters, if OP, this is 13 centimeters, then find the lengths of tangents PA and BC. We have to find PA is what and BC is what. Okay. See here, OA is radius and PA is tangent. Radius is perpendicular to tangent. So triangle OAP is a right angle triangle. And by using the Pythagoras theorem, we can find AP value. So hypotenuse square, it is OP square is equal to OA square plus AP square. We will get 13 square is equal to 5 square plus AP square. 13 square is 169 minus 25 is equal to AP square. 144 is equal to AP square. So here AP is equal to 12. This AP is equal to 12 centimeters. Okay. And we have to find BC value. We have to find this value. Okay. See, if there are two triangles and any side is asked, you have to apply the similarity property. See here, OB is radius and BC is tangent. So radius is perpendicular to tangent. So angle CBP, this is also 90 degrees. So this is also 90 degrees. And we will compare the triangles AOP and triangle CBP. In triangle AOP, which angle is 90 degrees? It is A. And in triangle CBP, which angle is 90 degrees? It is B. Okay. And P is common. We will take P here. And the remaining angle here is O and here it is C. So triangle APO is similar to triangle BPC. So we will take the ratio of corresponding sides. We will get AP divided by BP is equal to PO divided by PC is equal to AO divided by BC. Okay. We have taken the first two alphabets and we have taken the next two alphabets and next we have taken first and third alphabets and we have taken the ratios. So these ratios are same. Here AP is what? AP is 12 divided by BP. BP is what? It is 13 minus 5. It is 8. BP is 8 is equal to PO. PO is 13 and PC is what? We don't know what is PC. So we will not take this ratio. Okay. And here it is AO is equal to 5 divided by BC. BC. Okay. Here it is 4 into 3, 4 into 2. So here BC is equal to 10 divided by 3 centimeters. Okay. That's all for this video. Thanks for watching.